Hello students, I'm Mr. Giomini, making a quick video because I know some of you are a little nervous for tomorrow's midpoint quiz, and we will talk about that today when we get in class. Or if you're watching this later on today, we've already talked about it. So, taking a look, I just want to go back to the basics real quick of inequalities. And just to kind of touch base on, again, why do we flip this inequality symbol when we're dividing or multiplying by a negative. So just go to look at the first one. I just read it to myself. It says 7 times something, or 7x, is greater than or equal to 14. Now, again, when I see multiplication and I want to solve this inequality, I want to do the inverse of multiplying by 7. I can divide. Now, also, too, we know that dividing by 7 is the same as really multiplying by its inverse. So I can really also multiply this by 1/7. That would cancel those out, and I'm left with x. And if I, again, dividing by 7 is the same as multiplying by its inverse, so I could really multiply by 1/7. And that could change 14 into also a fraction. So that gives me, I'm going to find the common factors. 7 goes into 7 once, 7 goes into 14 twice. 2 times 1 is 2, so that says, hey, x is greater than or equal to 2. So if I were to graph that, and again, we're doing these with rational numbers. We're not going to immerse ourselves into graphing these, especially when you have decimals and fractions. So I have my 2 here. Now, it says x is greater than or equal to. That means 2 is included in the solution set, so that'll be a closed circle. And it's greater than, so it's going to go to the right. Now again, to check this, I could say 7 times, now it says x is greater than or equal to 2. So let's just substitute in 2. And let's see if this 2 still makes this inequality true. 7 times 2 is 14. Is 14 greater than or equal to 14? Yes, it is. Now we can also try substituting another number that is greater than or equal to 2. So let's try 10. 7 times 10 is greater than or equal to 14. Well, I know that 7 times 10 is equal to 70. And 70 is indeed greater than or equal to 14. So that shows me that 10 also is a number that makes this inequality true, or is part of the solution set that makes this inequality true. Now if I go down to the bottom one, looks very similar. It's not greater than or equal to, it's just greater than. Now this says negative 7 times x, or negative 7x, is greater than 14. Again, to solve for this, I can divide both sides by negative 7, or I can multiply by its inverse, which the inverse would be negative 1/7. Those 7's cancel out. So I am left with, let's see here, aren't I left with then negative 7? So let's see here, let's try this. Or maybe I'm wrong, let's see, what am I thinking here? Divide by, I'm left with, see, that's why sometimes it's worth working out. 14 times negative 1 is negative 14. This new active board, or this new slate, sometimes is touchy. Over 7, a negative divided by positive gives me a negative, so that is equal to negative 2. So now I would say, hey, x, if I left it as x is greater than negative 2. Now let's think about what that means. It means if I substitute in negative 2 into this inequality, it'll make this inequality true. So let's say I put negative 2 in there. So negative 7 times negative 2 is greater than 14. Well, negative 7 times negative 2 gives me 14. Is 14 greater than 14? No, it's not. It's equal to. Again, let's try another number just to prove this point, to drive it home a little more thoroughly. So again, I'm saying here that x is greater than negative 2. So if I take in negative 7, let's get a number that's greater than negative 2. How about 0? 0 is greater than negative 2, so I'll substitute in 0 there. And again, the inequality is greater than 14. Negative 7 times 0 is 0. Is 0 greater than 14? Absolutely not. So that explains why when I am multiplying or dividing by a negative number when I'm dealing with inequalities, I must flip the inequality symbol. So really, again, this would still be my negative 2. But now instead of saying x is greater than, now we say x is less than negative 2. So let's take a look back at this inequality and substitute in a value that's less than negative 2. How about, let's see here, negative 3. So if I substitute negative 3 now into the original inequality, erase my work here. So if I say negative 7 times a number that's less than negative 2. So what's a number that's less than negative 2? How about negative 3? Okay, negative 7 times negative 3 gives me 21. Is 21 greater than 14? Absolutely. So that makes that inequality true. So when I go to graph this, it says x is less than negative 2. So I can put a 2 in here. But now, 2 is not part of the solution set. Negative 2 is where it starts, but it's not included, and it's less than, so I graph to the left. Okay? So let's take a look at a story problem here. Jose is buying new clothes. He wants to spend no more than $125. He has spent $43.66 of his own money on a jacket. How much can he spend on other clothes? Okay, so I want to write and solve an inequality for this. So Jose is buying new clothes. Okay, he wants to spend no more than $125. So that means he can spend $125, but he can't spend more than it. So I know that whatever it is, it cannot be, so it must be less than or equal to $125. And I don't need to put the dollar symbol there. Now, he's already spent $43.66. Okay, so he's already spent $43.66. Now we're going to add to that whatever else he's going to spend on the rest of his clothes. So we'll call this N. Now I want to figure out what this N is. So how much more can Jose spend? Well, whatever I do to one side of the inequality, I must do to the other. So I want to figure out, well, how much is left? He already spent this, so I need to subtract that. So I'm subtracting that from his total. Now he's already spent that over here, so I'm going to subtract that from over here. But I'm going to line up the decimals here. I can put a decimal, 2 zeros here to line up that change. That cancels out, so Jose's left with N over here. N must be less than or equal to, let's see here, that gives me 10, so that is a 4. That gives me 9, so that is 3. Bring down my decimal point. This would be a 4, so that's 1. This would be a 12, and that would be a 0, so that is 8. So Jose could spend no more than $81.34 on the rest of his clothes. And I'm sure he's going to want this BLS t-shirt here. And Jose will know what BLS is. You can ask Jose if you'd like. But so he can spend no more than $81.34. Now to check this, I can always substitute this back in. Add these two together, and I should get $125. Again, Jose cannot spend more than, but he can spend equal to $81.34. If I take a look at this one, if 3/10 plus 7/10 is greater than y, is y greater than 1? Explain. So let's see, can y be greater than 1? Well, first of all, let's rewrite this. So we have 3/10 plus 7/10 is greater than y. Let's add this part, because we want to know, can y be greater than 1? That's our question. 3/10 plus 7/10, well, that gives me 1 exactly. Can 1 be greater than 1? No, can't be. So if I were to explain this, and I'll type since this is acting a little silly on me, I would say, no, y cannot be greater than 1 because it will make the inequality false, or I will put untrue. Y, let's see here, let's do the value for y must be less than 1 to make the inequality true. Okay. Hope this helps you out a little bit in your preparation for the quiz, the midpoint quiz tomorrow. We'll talk about it today in class, or we'll talk about it, we've already talked about it in class depending when you watch this video. All right, take care. Bye.